So you have to build for something where you're not preventing failure, you're kind of embracing failure and managing it. And that is very different to how all the legacy architectures are built.
Hello, I'm here with Peter Salanki, CTO of CoreWeave, the latest recipient of the SemiAnalysis ClusterMAX Platinum. The only recipient of Platinum. We had about 6 gold recipients, and we tested roughly 40 different cloud companies, but CoreWeave was the only one that achieved Platinum, and that's because of all of their great work on security and many other aspects, right? Performance, health checks, the list goes on. But this is more of a casual conversation. Peter, tell me, like, what's the history, right? Like, you guys were like crypto bros at one point. Like, what's up?
Thanks, Dylan. It's great to be here, and thank you again for the ClusterMAX Platinum Award. So crypto bros, we hear that a lot, especially now that we're public. That term goes around a lot, and it's true. Like, we do have our roots in crypto, and to give you like an abbreviated story of how I ended up here, the company was founded 2018-ish. Originally, Brian, Mike, and Brandon, they were working in commodities. They were running an algorithmic hedge fund that was trading natural gas. So Brian was kind of the author of the algorithm. And when you do an algorithmic hedge fund, you kind of don't want to be tweaking it all the time. So they were playing pool in the office while the algorithm was doing their thing, and they were betting Bitcoin at the time. They ran out of Bitcoin and started buying more Bitcoin. Brian was like, I can probably build one of these miner things. So they built a crypto miner in their office, and all of a sudden their colleagues in trading came around and was like, can you build one of those for me as well? So they started building miners and selling them to people. And I'd kind of done a mining thing on the side as a hobby, and I got in contact with Brian on like an Ethereum developer call, technically. And in crypto, like, most people are very diehard, like, crypto is our thing, and I'm pretty crazy about it, and are also not necessarily that skilled technically. So I heard Brian talking, and this guy actually knows what he's doing. He's not just someone who thought they're going to be a billionaire by buying some AMD GPUs from Best Buy. So I hit him up and I'm like, who are you? Like, what you are doing? Like,
Instead he bought NVIDIA GPUs from Supermicro and became a billionaire.
Yeah, so exactly. That's kind of how it ended, right? So I hit him up and I'm like, what are you doing? Like, what is your deal? And he's like, okay, this is the plan. This is 2018. Like, Peter, we built these miners for other people. We don't really have any on our balance sheet. But what we're going to do is we're going to raise some money. We're going to raise some seed capital. We're going to sit on the money. And then in 6 to 9 months, the crypto market is going to crash. We're going to buy all the used GPUs from all the miners are going to go bankrupt. And then when that happens, we're going to both mine and we're going to use the GPUs to build a cloud. Can you build a cloud for us? And I'm like, this sounds insane. Like, if everything that if everything you do plays out, right? You raise this money, you sit on it, you get people to invest money in your company to not spend them now, but to spend them sometime in the future when this crash happens, and you can actually buy all these GPUs at cents on a dollar, I will join you guys and I will build a cloud. Like, how hard can that be? And then it actually played out. Crypto crashed like beginning of 2019. I joined the company, quit my job. My background is in infrastructure, like service provider and vendor side, mostly networking type equipment. I quit my job. I joined CoreWeave. We bought 40,000 GPUs initially for $3 million. These are then mostly like consumer GPUs and some mining SKUs. But it was a lot of GPUs for literally nothing. And then we started building a cloud, and we started building Kubernetes and lifecycle systems, which turned out to be very, very useful even later on. So even though it has root in crypto, and we definitely bootstrapped us with crypto revenue, like from day one, we were building a cloud.
That's interesting. You mentioned like this lifecycle management stuff, right? You're buying the worst of the worst, right? Crypto mining GPUs where fans could be broken, or like...
Yeah, in some cases we even ripped up the fans because like they were not working and we were just pumping air on them.
Yeah, exactly. Or like, I don't know, like they've just been sitting in someone's basement and it might be 80 degrees or 90 degrees in there. And so now they're like...
Best case.
They're like horrible, like, they could be unreliable. So you're dealing with unreliable hardware from the start.
Yeah. which turned out so well. So we're dealing with unreliable hardware from the start, and then we're like, okay, what do we build around this to actually make this super unreliable hardware useful for other things than crypto mining? So, I mean, I'm a big Kubernetes guy. Kubernetes is very natural because you have, containers essentially stateless. So we built this system around it where we, plugged in 40,000 consumer GPUs, and then we could take workloads that didn't care if a small piece failed, which is different than, large training clusters today. But back then we did a lot of molecular dynamics and then moving on to inference that we could do on these consumer GPUs. And since we had the scale, we could all of a sudden go after customers who could only be served by the hyperscalers, because these are people who either needed, 10,000 GPUs. And particularly in the beginning, we went after people who, okay, I need 10,000 GPUs, but I only need them for, a day a week. And it was incredibly expensive for them to run on the hyperscalers, and all of a sudden we could serve them when no one else could. So that's how we got our foothold in, and then we went to inference, some really bursty use cases. We could also do it really cheaply back then. And then we started building all these technologies on top of this base platform, which was really Kubernetes with a lot of health checking. Then we built some inference stacks on it, like runtimes for running batch jobs and so on, and kept building from there.
Interesting. And so how did this, so these were still consumer GPUs at the time. How did sort of that level up into data center GPUs, right? Because you bought sub-market rate GPUs at the time.
Yeah, and they were
$3 million for 40,000 GPUs is like
insane.
It's like
it's like 1070s, 1080 Ti's, some P102 mining GPUs. But they were very useful. Like the 8 gigs of VRAM back in 2020 was great for running inference on, right? And then
especially for ImageNet models and things like that.
ImageNet. We started up GPT. I mean, then we could start running like GPT-2 and we had 16 gig GPUs. We could run GPT-2. Was it 1.75 billion parameters back then? And then we got into with a company called AI Dungeon. They were our first big inference client. They were the first ones who took an LLM. They took the open source GPT-2 and then a bunch of prompt engineering, turned up temperature to the max, and it created this Dungeons and Dragons game.
Oh, wow.
It was pretty cool. Originally it started as a collab notebook, and then they built an app around it, and then people were making their own stories. None of it made sense really after 3 prompts, but in 2020 it was amazing. And they burst it up, and we had a bunch of users from their GPUs. We also did VFX rendering, worked out really well. So we started having the business going, started making some revenue, started getting intros to people, and then NVIDIA reaches out and it's like, hey guys, we're hearing about you. And then timing worked out really well for us, because now we're in 2021. Crypto is all of a sudden roofing again, and we go to offload all our GPUs, all our consumer GPUs, and everyone is like, you guys are idiots. These are gold mines, and they were making us back then a huge amount of money per day in the peak of crypto. Literally printed gold, kind of.
Yeah, I mean, I think for context, at peaks of crypto, you could buy a GPU and pay it back in 9 months.
No, I mean way shorter. It was payback.
Even shorter. Okay,
yeah,
wow.
At some points the payback time was.
I'm talking about brand new retail.
Yeah. Yeah. But even in the peak when the supply constrained, the payback time was 2 months, but you couldn't get any. So they were.
Is this for Ethereum or Litecoin and things like that?
Ethereum.
Okay.
It's all Ethereum because of GPU. Because our plan was always to be a cloud.
Yeah.
We always wanted to get away from mining, so we never did an ASICs or anything like that. So then we started selling these GPUs to other miners, and people were like, "You guys are insane! Why are you selling these?" And I'm like, "We're selling them because our long-term strategy will be a cloud, and we can't violate the EULA, so we have to get rid of them." So we sold all the all the consumer GPUs for 10x what we bought them for, and we turned around. We bought data center GPUs and deployed them. And they make a lot less money mining, but now we're fully set up to actually compete with the hyperscalers.
What were you buying mostly, A40s and
so we were buying A100s and A40s,
and
then also some RTX line, RTX 4000 was a great RTX 4000. Yeah, but the RTX 5000 has in a sweet spot. It had 20 gigs of VRAM, and it was really good at inferencing 7 billion parameter models. Mm-hmm. The RTX A5000. So that was also a great inference chip and a great VFX chip.
Wow. Okay. So now you've offloaded these GPUs. You've got some A100s, A440s, A4000. Sorry, and some various other GPUs. it's still 2022. AI hasn't taken off yet.
It's even 2021.
It's 2021, sorry. AI hasn't taken off. GPU clouds are not that big of a deal. I think back in these days, a lot of people were still running like the T4, and that chip is ancient, but like people were running that a lot. The workloads were, it seemed, at least from my viewpoint, the workloads were quite sparse besides training on language model side. So were you guys in training yet, or was it primarily still inference?
It's primarily inference. So then it was like split. VFX was probably half, and inference was half, and we had a really sweet spot in the models that you couldn't fit on a T4 because they were too big, or yes, T4 was like dog slow, and A100 was too expensive. So like this 7 billion parameter space, like there was, all of these like startup Novel AI was an early customer, like that pop up, they do stuff with LLMs, they really don't have anywhere to go, and we had a really nice solution, auto scaling, like all the things just work, they just pop in the model, and like we get an inference endpoint. So we had a really good solution for that. So we started to see some traction there while we were still investing heavily in the VFX business, which also like the T4 A100 is terrible for VFX, to be honest, and the VFX business during COVID had to make a big pivot because they were all working on-prem. But all of a sudden you have to work from home, and now they can't send these beefy workstations to people's home. They need to protect the IP, so they need the virtual workstations in the cloud, and all the kind of the VDI solutions that existed were also pretty bad, and we could have really good GPUs, get a good fit for that, matched it with really good storage, and could build a really good solution for a VFX studio in the cloud. What
sort of stuff did you guys do to protect security there, to enable virtual desktops? That's very different than AI, sort of like a single tenant workload almost, right? But on shared infra and with high speed storage, right? Like explain like how this like comes together on that front. Yeah, and it sort of seems like the building blocks, right? Like,
it's the same building blocks, and it's kind of like table stakes. If you want to build a cloud, right, you need to like build a VPC infra. You need to have strict isolation. You still need to be able to be dynamic. Storage, we built most in open source technologies then, but had to build isolation in very early. Deal with like noisy neighbor issues. Like all of those are painful things that you have to figure out if you want to be a real cloud player, right? And especially if people want to be elastic with their storage, right? An easy solution would be like, okay, I'm going to deploy one storage cluster per customer, but it doesn't scale if you want to be elastic and people want to consume on demand. So we had to build out all those things. For virtual desktops, we did virtual machines. We don't really do virtual machines anymore. We do like Kubernetes on bare metal because it's better for AI use cases. But for the VFX, we did virtual machines so they could get a virtual desktop. We had their images. They had all like network policies. We had cloud firewalls we built, cloud VPNs to take them back to their on-prem, like storage caching solutions. Like we built out all these things so they could have their little studio in the cloud, and people couldn't exfil data out of it. And since it was a virtual machine, you also couldn't copy anything. Since it was a virtual desktop, you connect to it with software like Teradici and Parsec. People couldn't even copy like the data locally to their laptop they were working from.
Can you walk through sort of like, so this is still like bursty workloads or single GPU workloads, which is still part of your business, but the vast majority of your business is actually not that, right? It's long-term contracts on humongous blocks of GPUs. So how did that change?
Yeah, so then the VFX stuff, none of it was. It was some long-term contracts, but it was still bursty. And the individual artist was working on a single GPU, but then when you go and render. And this is, again, where like the early scale we had made all the difference. Because when you go and render, we could all of a sudden launch a render job on 10,000 GPUs. And, instead of it, and these when these VFX studios were on-prem, they maybe had 100 GPUs. But for a render job, like it scales 0.1. So if you have, 100 GPUs, it takes, say, 100 seconds. If you have 1,000 GPUs, it takes 10 seconds. So we could all of a sudden have their rendering jobs done in like 10 for 100th of the time of their on-prem clusters, and they're like, wow. And since we had so much capacity, we could, mix all the different customers in, and we didn't really have a capacity crunch at that time.
What were can you talk about which sort of VFX studios these were? Were these like big names in the industry already? Or?
Some of them were big names. I honestly don't know which I can mention. Most of them are still our customers. Obviously, kind of dwarfed in scale, but some of the AI. But these are people you've seen it on your favorite TV shows, like HBO. A lot of great HBO shows, like everything you've seen on.
Got it. Okay, so you did have large-scale workloads that bursted across the whole cluster, kind of similar to AI, right? You know, a lot of times you'll get a big cluster, a research company like a lab like OpenAI will have a research cluster, mostly be running a bunch of small jobs, and then all of a sudden they'll burst out and do, you know, a large run on it for months at a time. It's still a bit different, though, right?
Yeah. And the big difference with VFX is that it's easier because all those things they're parallel, they're not interconnected, right? So when you go into training, they work together. In rendering, still you can have one failure. Okay, you have to re-render that frame, and we built all the stuff again for like retries and so on. But the entire job doesn't stop.
Yeah.
So the training is always the next level. So we started doing that, and then we got in with an open source collective called Aloof AI. This is when OpenAI launched our GPT-3, and this crew were like, we want to build an open source, better open source LLM. And we said, okay, we want to be part of that. You know, we want to get into training. We want to learn together with you guys, and we want to help be a part of this. So we started, we connected. That's when we started building our first InfiniBand cluster.
Do you hang out on the Luther Discord still, Peter?
Not anymore.
It's a wild time.
Yeah, I don't. I just don't have time. I used to, like when we're training, but I just don't have time.
Shout out to the Luther Discord, though. It's really fun to be on if you're trying to learn about AI on a technical level, or just, you know.
Yeah, and there's some really talented people there. So we started out in 2021, you know, just when we built our first InfiniBand fabric with a bunch of A100s. Like, I had to learn everything about InfiniBand. How hard can it be? Turns out it's still hard. And we, you know, there was like, I think the first cluster was like 32 nodes. So we're trying this together. We trained this 20 billion parameter model over like 3 months. It was done by Christmas 2021. I think, and then we released open source, and like, it's not necessarily the most groundbreaking model ever, but there's a lot of good things came out of it, right? We open source together with Luther the data set, which people still trained on up to like last year, and how the model's built, and all the infra piece of what went into it. So it was a great, I think, great learning opportunity for us, and also gave something back to the open source community. And that's how we started that's how the training journeys kind of started.
So end of 21, you've already had you've done some small scale large language model training, right? 128 GPU clusters, nothing to scoff at, although it's like still dwarfed by today's scale. You've got 256, yeah. You've got this big VFX business and inference business, right, which are very elastic, ramp up and down. So you've got good revenue coming in the door, and so you sort of where did you get the conviction that like AI is where you actually want to invest instead of VFX? Because VFX is you're dealing with real companies that have storied history, good revenue. You're servicing this market. Why was it like, no, actually we want to go all in on AI? So like, when did that decision come? Because it came faster than anyone else. You know, late 22, I guess. At least from external view, it looked like, oh, why is CoreWeave going all in on AI? And I believed it at the time. Other people did, but most people didn't believe it at the time, right? So what made you guys go all in on AI?
So I think that, I mean, looking at our company, our success, it's not really random. And, you know, going back to the story I told you about how we were founded, like especially my co-founders, Mike Brannon, they're very good at seeing signals and being strategic about them. So they see signals very early, and then we plan out, okay, how do we, then it's about making kind of asymmetric bets, right? So how do we see that this AI thing could pop. Like, what do we have to do to be in a good position to take advantage of it without necessarily risking the company? So what we did was we went out and we signed up a bunch of data centers that you know, I thought was a bit insane. Like, we're signing up 10 megawatts of data centers. Like for delivery in like 6 months, like, are we gonna fill that? That sounds insane. It's like, okay, but if we don't fill it, if we have them and this thing actually pops, then we have them and we can take advantage of them. If we don't, yeah, we might have to be paying for, you know, some unused data center space, but the risk reward is so high. So we went out and placed these very strategic bets that we knew even if they didn't play out, the company wouldn't go under. But if they played out, we would be in a very good spot. So that happened in the end of 2021. Then we get into 2022, say that half our revenue is still from crypto mining, because obviously when the GPUs were idle, when they were not rendering or running inference, we had a low priority daemon set, spun up a crypto miner, minus some Ethereum. So we were always making money on GPUs, and that we're paying for everything as we scaled out. And then 2022 comes around, there's more inference customers pop up, like you feel things happening. And then I think the next big pivot point was the image models. Stability AI launched their image model. They came to us because of all the work we've done with Aluther and also open sourcing of inferencing of open source models. They're like, guys, can you help us build an inference service around this? Can you help us run inference on Stable Diffusion? And they did that. Came to us 2 weeks before they actually launched the model, and like we realized we need an inference API. Can you build this? So me and a bunch of my colleagues, we didn't sleep for 2 weeks, and we built them like an inference endpoint where they could, people could put in credit cards and they could buy tokens to run Stable Diffusion, and we had auto scaling up and down, and like everything we built kind of so far felt like was for this moment. So we launched it. Stable Diffusion went viral. Everyone wanted to play with it on Stability AI's website. There was one day I'm like on my way home from somewhere, and like everyone is freaking out because the autoscaler is scaled up like 10,000 GPUs in a minute. And like something is wrong, and like we're trying to figure out why the autoscaler is going crazy, and then we find out that some YouTuber had just posted about like Stable Diffusion and how cool it is, these image models, and like we just got the traffic, and we scaled up and pulled GPUs from all of our different data centers, which then a bunch of them were actually real data centers, a bunch of them were still like mining data centers, and like everything worked, and we scaled up 10,000 GPUs in a minute, and like it was pretty awesome.
Well, and the service didn't break. You now believe like the virality of Gen AI, right? Because the diffusion models were the first Gen AI models, right? Now it's about mid-22 roughly, right? You guys get conviction and what? You YOLO into more data centers?
Yeah, pretty much. I mean, yeah, we like, okay, we showed up capacity, and then we start talking to some real AI labs, right? Like first we signed some deals with Stability AI, both for inference and for training. So we built some significant A100 capacity for them, and then we had some other smaller labs that we're still talking like the thousands of the GPUs, but we started going, and then then we became pretty good friends with NVIDIA because they saw how elastic we were, right? Like, okay, there's a demand, Stable Diffusion is out, like these guys can deliver, they can do so quickly, and they do it with high quality. Mm-hmm. So they gave us some intros to some potential customers, and we started talking to some more and more real AI labs, and then we started talking, like things are moving, and we're like, okay, wonder, like something's going to happen here one day, like something big is going to happen, and then like it's going to kind of unlock everything for our scale, is kind of how we looked at it. And about the same time, now this early fall 2022, the H100 was coming out, and this is like, previously we had never raised any capital since the initial $3 million. And now we want to make a bet on H100s. And again, the bet is kind of, let's buy a bunch of H100s, let's get them online, and if we can't sell them, then the market is not there anyway, so it's an okay bet to make. So we raised money. We raised $100 million, which was an insane amount of money back then, and we bought $100 million worth of H100s. So we're going to be first in the world with H100s. We're going to have them up, and then when we have them up, we'll probably be able to sell them. That was the plan. Then all of a sudden, so we're executing on this, starting to build, getting ready. ChatGPT drops, and kind of the world goes insane. And then we had this $100 million worth of A100s or H100s. They were sold out already in early December before we even had received our QS sample. And then, like by 1st of January, we had like $300 million worth of, I don't know, that might be correct, but somewhere between $200 and $300 million, I think, worth of H100 contracts written.
Get services online with H100s before every hyperscaler by a factor of like as much as like 6 months in many cases, right?
So there's a couple of parts to it. The first part is that our life is a bit easier because our stack is simplified and built only for AI. So we run, we run Kubernetes on bare metal. We also have a Slurm on Kubernetes that runs on top of that, but we don't have a VM in there. That's both for performance reasons and also to make it simpler, right? The researchers get to see the hardware as it is, and we don't have to worry about like what weird interactions might a VM have with the hardware. So that just made it a bit easier that we don't have all this legacy tech that is really built for CPU workloads kind of stepping in our way. And the second one is kind of being ruthlessly aggressive, deploying these things, expecting failures, and then not sleeping. and being lucky to have some really good people on our team. Really good people on our team, but still being a small team, so we were not weighed down by process. So like we start digging into this, we all of a sudden become very good friends with the hardware teams and software teams at NVIDIA, because we're finding issues before anyone else is, and we're willing to take firmwares that are fresh off the presses, get them out there, test them again. So very quick iteration cycle. And the third step, and which is what actually led us to pretty much where we are today, is all the stuff we learned around lifecycle, health checking, how important it is to weed out GPUs that might not be perfect from the consumer GPUs days. As I said, I didn't expect it, but that really paid off in spades, because we could build on all of those frameworks we built to immediately take GPUs out of production, right? If a GPU had a signal or something bad, as even XID79, we detected immediately, took it out of production, replaced it with a new system in the customer's reservation. So we could do all this life cycle automatically, because we built it for something running on consumer GPUs that came from a barn. Essentially, we could apply it to these early life technologies and make them work really well.
Interesting. So that is one of the things that separates sort of CoreWeave from other clouds, is that they have a much more reliable infrastructure, right? Part of this is burn-in scripts. Part of this is active health checks. Part of this is passive health checks. I guess what do you think? I mean, and today this is still the case, right? There are still many clouds that don't do these things. And even some of the top clouds don't do passive health checks or active health checks, right? In some cases, right? Whereas you folks, I think, just schedule a job. Can you talk a bit about the sort of active and passive health checks you do?
Sure. So I mean, there's a couple of steps in the life cycle of a cluster, and I think that if you compare the hyperscalers with what we do, a lot of their processes, everything is built around how compute has looked over the past 20 years, and not necessarily how it looks with these AI use cases, right? So I mentioned CPU compute, hypervisors, all of these levels of the stack, they're all built around the server, and the server doesn't necessarily talk to other servers directly, and if one fails, they rarely fail, it's a CPU, what's going to happen? And as a cloud provider, you also don't really want to know what's going inside. It's not in your interest to be integrated with their workload schedulers and so on. So we very early, as a rooted back to the consumer GPU days, realized we need to flip this on its head for these type of use cases. Because even when, you burn something in and something is in production, it's kind of a living, breathing machine. These things are so complicated. They're so interconnected. And you don't want redundancy, right? In a traditional, hyperscale environment, if you have a network link, you're going to put two network links there, so in case one breaks, that's fine, customer's not going to know. If I tell my customer that, hey, half of these 3.2 terabits of InfiniBand on a node, I'm going to use half of redundancy, only going to get 1.6, they're going to tell me to, go do something. I
admire your ability to censor yourself.
Yes. I don't want to get in trouble. So you have to build for something where you're not preventing failure, you're kind of embracing failure and managing it. And that is very different to how all the legacy architectures are built, where you burn something in, it's fine, and then you kind of throw it over a wall, and then you don't know what happens. And all of this, if you want to operate at any scale, all of this has to be hyper automated. Because you need to respond both quickly, and I also don't want to have 10,000 people around looking at Grafana dashboards. So we started automating it very early. Also was a factor of having very few people when we started out. So built everything automated. So we started life cycle with validation checks, simple things that seemingly everyone doesn't get right. Your cable correctness, right? Is when we build a data center, we have tools that pulls from database, everything kind of original data center designs come via Netbox, and then we generate all the cut sheets for every single cable in a data center, right? And the number of cables can be anything from 40,000 up to 800,000, depending on the size of the cluster. So it generates essentially an 800,000 line spreadsheet, which has every A to Z connection in the entire data center. So now we have a data model on how it should be, what is the blueprint, and then that goes to the cable contractors. When we build these really big clusters, we talk about up to up north of 100,000 GPUs, there is 300 people in a data hall pulling cables. there are going to be mistakes. So you have to assume there's going to be mistakes. So when the node or a cluster comes online, we automatically pull all the peer info, right? Like Ethernet, LLDP, InfiniBand, have exporters on the node, so we get the full map of how the network actually looking, compare that to our blueprint that we generated, and then we can create correction lists both in the fabric and then on a node. If there's a node link flipped, say that you have 8 InfiniBand links on a node and 2 of those are flipped, like you're gonna have 8 links up. And you might think that everything's fine, but then since InfiniBand is rail optimized, your performance is actually going to be terrible, and your collectives are going to be like super confused if you try to run a job with that. So,
when did you guys have this this sort of mapping stuff built out?
This was already like this is like 2023 when we started building clusters of scale. Because we went from like 1,000 GPUs to like 6,000 GPUs to 16,000 GPUs in a span of 4 months. We had to like go from kind of crawling to running like incredibly fast.
I mean, that was a really pivotal moment, right? Sort of as like, you didn't have hyperscalers as customers, and then all of a sudden you have hyperscalers as customers with contracts written, signed, and you're like, okay, looking around and you're figuring out how to get the financing and all this sort of stuff. But you've got this big contract with this big hyperscaler, so people will back it. And so you scaled like crazy in that.
Yeah, we scaled, and then we had to figure out the tech. And like part of it is, we had a good base of systems, and we built on top of them. Realized that if we don't systemize this immediately, we're going to get in trouble. When we also managed to hire some really good people. So one of the kind of lucky breaks we got was that DigitalOcean. In 2023, they laid off a bunch of really talented engineers. And they were looking for a cloud with a great working environment to come work for, and then we managed to scoop up a bunch of them, which was awesome. So we got some really good network talent in there that could help us scale and build all these processes.
I guess so.
They also had great product people.
So you've kind of skipping forward, right?
Yeah, sorry.
To sort of what's going on today, right? It's still the same thing, right?
Yeah.
You've gone from 4,000 to 16,000 to 10x that number again, roughly. You've got people. You've got a new generation of GPUs. These GPUs again are going to be hard to ramp up, right? There's tons of challenges in manufacturing. There's tons of challenges in deployment. There's tons of new technologies coming.
Yeah,
that make it so good.
NVL72, like super complex. That's a completely another dimension. Like it's not just a layer; it's another dimension of complexity.
Right. So because you have the liquid cooling and the NVL72, there's tons of new data here.
Yeah.
There's
from the topology perspective, like we have InfiniBand, we have Ethernet. And then you had a server previously. Now we have 72 GPUs, 18 servers that are in another domain. So from a scheduling perspective and a maintenance perspective, it's not just a layer, it's another dimension of complexity, which is so hard to be honest.
And then within there, you also can like slide out like just 4 of the GPUs if you want to, and
you can slide out a compute tray. But then now I need to burn it in, right? And if you have a security conscious customer, they're not going to want you to burn it in. While the NVLink, which is a memory fabric, is they don't want you to run your burn-in while the rest of the trays, the 17 trays, are in their partition, running their job. So we have to dynamically reprogram the partitions to be able to hot swap a tray. So it's a bunch of orchestration and so on that goes into it to be able to do it securely.
Interesting. And then. I'm guessing
now we jumped way ahead to current.
Yeah, I mean it's just a question of how you keep scaling, because it's logical from the end of 23 to sort of now, but this is sort of saying, hey, why are you winning now, right? Yeah. And so you've got all these challenges that continue to come up. You've got competitors, whether they're hyperscalers or other cloud companies, just aren't moving fast enough, right, on some of these topics, right? Which is why I think you guys announced with NVIDIA, the first sort of 100 rack or so system. What is that? What was that?
Yeah, exactly. We're live. I think we're first in the world with live scale production customers. It's taking an insane amount of work. I mean, I don't think my hardware team hasn't slept since October to get here. And there's a lot more work as we scale this to much, much larger clusters. And as you said, there's a lot of stuff to it, right? Not only the NVLink design, the liquid cooling. Thankfully, our OEM partners, their liquid design has been really solid. We haven't had a lot of problems with liquid. We anticipated to have more problems. Like there's been no green goo over any data center floor, which we're really happy with. And the other benefit that we have against kind of the traditional hyperscalers is we're not trying to retrofit these things into like old data centers. We can build, greenfield and have proper facility liquid, no like sidecars that you'll see in some photos and so on.
Yeah, so sidecars being the massive radiators next to the server.
Yeah,
I think it's kind of poetic, right? Like, sort of this brings up the sort of topic of maybe one of your biggest data centers, or at least definitely one of the most interesting data centers you have, right? This is in Texas. You used to be into crypto, and you're doing crypto mining, and you bought a bunch of used crypto mining GPUs, and now you're buying crypto data centers from crypto companies.
Kind of full circle, actually.
Right. And you're converting them, right? It's and it's a complete different it's a complete rehaul of crypto data centers. What can you talk a bit about that process of like what's going on, why that lets you do full scale liquid cooling so much faster than other people? And it's like public, right? That many major companies like, Meta and Microsoft and Google and Amazon are all doing sidecars, where it's like sort of, okay, we're going to do liquid cooling on the server, but then we're going to pump it to a radiator, effectively a massive radiator right next to it. Yes, they're doing full liquid cooling as well, and they're working on those designs, but you guys have fully liquid cooled data centers.
Yeah, we don't do any sidecars. So sidecars, again, is this big radiator, like it's bigger than the actual rack itself, because it takes, and if you think about data center cooling, right, like you have a chiller outside, then it goes liquid into the data center, and then there's an air exchanger, just like your AC at home. There's an inside like fan, basically takes the warm air, cools it down with a liquid, and makes it into air. And this sidecar then takes the air that was once cooled by liquid, turns into liquid again to cool the chassis. So it's like a 3 times conversion, makes 0 sense, and your PUE skyrockets. So having to do that is not great. So I'm very happy we don't have to do the sidecars. And then going into your question about like the Texas facility and other kind of ex crypto mining sites we're contracting with. So we built all the systems I talked about and the processes, and we didn't talk that much about burn-in, how we do our own burn-in, and then run NVIDIA's burn-ins on top of that. Like, we built this system that allows us to build clusters, get them online in weeks from like when we have access to the facility. But if we don't have a facility, it doesn't matter how quick we are bringing them online, right? And when you look at the supply constraints for data centers, like a lot of people are freaking out about power. Like, the problem is where you have power, where you can find generation. And if you start peeling the onion, there actually is quite a lot of power in the US. There's like, if you go out to North Dakota, there's high voltage lines with hundreds of megawatts of power you could tap into. But you can't take a GPU or a GB200 chassis and tap it into a 13 kilovolt line or 120 kilovolt line. You're going to fry that thing pretty bad. And then you need substations, you need transformers that are insanely long lead time items. But something that the crypto miners has got is they got a lot of power. They might not have anything else, like literally nothing else. They might have a tent, but they have substations
cooling systems are
and
hilarious.
transformers. There's no cooling systems, right?
Right.
We were mining, like literally cut hole in the sides of the buildings and put a fan there, and that was the right thing to do for crypto mining. Not the right thing to do for GPUs. I do not recommend it for doing anything but mining. But they have the power infra, which is the long lead time items. So by taking the kind of crypto miner data centers, we have the long lead time items there, and then we can build new buildings, put up new chiller plants, which we can do in much shorter times.
Yeah, and this is interesting because it lets you get to these, call it $10 billion clusters, right? In time scales from project start to completion that are much shorter than anyone else, right?
Yeah, I mean, it's measured in months instead of years.
Yeah, exactly. And we've seen data centers that are being built the traditional way, where hyperscalers were like, oh yeah, this is going to be a massive data center. They start building it in 2023. The thing is still not done, right? Even if they had the electrical equipment in not on lead time, they paid a bunch to skip the queue, right? They're still building the data center slowly, getting everything together. It's just a complicated thing. And you guys are able to sell it and get, $10 billion contracts or more or whatever for these massive sites.
Yeah, and I mean, getting customers for them are not easy either. But like, we've proven like the other thing that I think that has gone really well for us is that we're good at making commitments we can keep. And like when you're dealing with, the AI labs, like type of customers we're dealing with, they're in a race to build AGI essentially. It's a moon rocket we're building, and if you make them a commitment and then you don't keep it, like you lose all your credibility. And we've been really good at making really big commitments, but actually keeping it. And that's again a combination of knowing what you're doing and also working really hard to make that happen. Because there've been a lot of crazy situations where, we had to be very creative and work 24/7 to actually hit the deadlines. But we've done it, we delivered, and now we can get people to sign like really big, impressive clusters with us because they know that we're gonna hit our commitments, and we're gonna do everything that is humanly possible to get there.
So we talked a lot about the speed to build. We talked a lot about the reliability angle. The other thing that is important when judging sort of ClusterMAX, and the main thing for us when we're evaluating all these clouds that really impressed us about CoreWeave was the software side, right? Yeah, you can do bare metal. Anyone can do bare metal. Major customers want to do that because they have their own software stack. But in many cases, customers want Slurm. They want Kubernetes, and then they want this weird thing that you have called Slurm on Kubernetes. Right? Can you talk about sort of these three software stacks, especially the latter? Why? First of all, at first when we first looked at CoreWeave, we were like, "This.
What is this thing?"
Yeah, we're like, "What is this thing?" I just want my normal root directory. I just want my normal things. This is annoying. Why do I have to do it differently? Right? This is literally our first reaction when we first started using CoreWeave, and we were like, "Oh, we really like these other clouds more." And then it took some time, and we're like, or it didn't even take that long. It just took a little bit of thinking, and it's like, oh wait, this is way better.
Yeah, I think you didn't even have access to the docs or anything when you tested it the first time, so
yeah,
we
kind of YOLO'd it.
Missed the intro, yeah, classic YOLO.
That's because we didn't get it through you, right? We got it through someone else, right? It's a little
because we were sold out. We're perpetually sold out, I feel like.
We do the thing to get access. We go about roundabout ways, right?
Yeah, so I'm gonna answer your non-question first before I answer your question. So you said the bare metal is easy, and I agree. Bare metal is easy if your use case is you buy 1,000 GPUs, you throw them up there for a single customer in a single network, you never touch them again. Customer, you go have fun, figure out all the problems. Bare metal is still hard if you have to be responsible for burn-in, break fix. And you also have to add some security, right? Both, even if it's a single tenant environment, you want to isolate yourself from your customer's environment while you do all the repairs and so on. You don't want your burn-in, you don't want your techs that you don't want your techs that eventually are going to have to get on the system in a shell at some point to troubleshoot something. Even if you have the automation, at some point there's going to be some bug that requires someone to get on a shell. You don't want them to sit on the same network as your customers. As customers running production workloads. So even in the bare metal use cases, right, you still need the network isolation. We do that using the NVIDIA Bluefield DPU in the nodes. We have our own software stack running on that. So we terminate VPCs on a chip that we control inside the node, but then it's fully separated from the customer's environment. So when we have a bare metal customer, even if it's single tenant, even if it's a single tenant campus that we build with 8 buildings and 100,000 GPUs, they all run the same stack where we have DPUs and we have then essentially 2 VPCs. One for the customer, where they run the production workloads. One for us, where we do the burn-in and break fix. So they're always separated in any scenario where we do our work to burn these in to make sure that once they flip over to their stack, whatever it might be, if it's Slurm, Kubernetes, they're going to work. They're always separated from a security point of view, which is super important. And then if you do bare metal multi-tenant, it actually gets even more complicated because then you have to worry about stuff like one tenant accessing the BMC and doing something to leave persistence there, and then that node getting assigned to another tenant over time. So doing all these protections to lock people out from BMCs, lock people out from manipulating GPU firmware, that's a lot of work.
This is actually some stuff that we've noticed on other clouds. That we've tested, whether it's things related to InfiniBand P keys, and we're able to snoop in other nodes of real live customer traffic, and obviously we tell them yo, this is not okay, or accessing other servers' BMCs even. There's some silly stuff that we can do, and we only have a few engineers, right? It's if you're a really dedicated attacker, I'm sure there's a lot more complicated attacks that could be done, and so that's important.
Yeah, and doing this stuff on VM, you get a bunch of these protections for free. Doing it on bare metal, it's harder. We have our own. We have pretty significant security team. We have our own in-house red team that it's a team that's only job is to break out from they give a customer environment. Their only job is to break into another customer. If they break into another customer, they get bonuses. So far, their bonus pool is regretfully pretty low. And then
not a good job.
Yes, it's a great job. Actually, security people, we need more of them. Okay, our mission is very important. And then we use external pen testers as well. When we do external pen tests, like we're always on top of this because it's so critical, the isolation between customers, right? And even between customers and us, even the level of customers that we have, right? If I can build a system where even if they manage to attack me, like I can't necessarily access our customers' data and their models, like that's the system I want to build, and that's what our security posture is. So that takes the bare metal piece, and then like even with our Kubernetes Slurm, like all of the stuff builds on top of that. So if we have a really secure base with really hard isolation, then I know we can build stuff on top of it. So then we originally I talked about how back in the day we built Kubernetes, and why we built Kubernetes was like, I'd like to say there was like a huge master plan in there. It was mostly like I like Kubernetes, I like containers. Like to me, as a super nerd, it was a very natural way to orchestrate compute. That's not the case for everyone, apparently. But for me, it was very natural. So I'm like, of course, we're going to build this all around Kubernetes. Like, who wouldn't love Kubernetes? I was right for the most part. There's some people are like, why are you so attached to Kubernetes? But for the most part, I was right, which is good. But I could also be very wrong. I didn't do like a huge market study. I just really like Kubernetes. And then we got into training. All of a sudden, I have all these people, like especially people like old HPC background, like we want Slurm, we love Slurm, and I'm like, let's look into Slurm. I'm like, this thing like really doesn't mesh well with Kubernetes. And it's like, should we start running Slurm on bare metal? Like, what about all the life cycle? Like, should we try to retrofit that? Like, should we build an agent? And like, that seems messy. Like, let's try to. And like, how do we then manage these things? Even if I had running a bare metal, it's like, we have to do a bunch of Ansible jobs. I'm like, Ansible, like mutating state. Like I like, containers and our OS image, like everything is immutable. All you have to do is reboot or restart something is back to the known state. Like mutating a bunch of file system and stuff that felt very awkward to me. So I'm like, let's try to build something where we give a native Slurm experience to the users that SSH into their logging pods and do their stuff. But from an admin's perspective, they can use all cloud native tools like Argo CD, GitOps, and so on. So that's how Slurm and Kubernetes came about. Initially, it was like a Helm chart with container wrapped Slurmds and stuff, and a bunch of really, really messy Helm, and then we built it into a proper operators, proper controllers, integrated with our lifecycle, which is a very big thing, right? So we can reflect health status between Kubernetes and Slurm. We integrated the Slurm schedule with a Kubernetes scheduler, so you can have Kubernetes pods schedule in Kubernetes for your inference, and they actually schedule like in Slurm. So you can use advanced scheduling features from Slurm, but you can still have your inference running nicely contained in a container. So we integrated all these things, made them work really well, and made it so that the Slurm behaved like Slurm, and had a whole bunch of integration layers to then translate it into like a Kubernetes world, and not just like Slurm components thrown into a Helm chart, which is kind of where a lot of the other projects are.
What sort of did it take? I guess like zooming out a little bit, what did it take to, or what is the reaction, right? Like I mentioned, right? Our first reaction when we saw it, we got it without looking at having your docs. I think it was the same happened with how we accessed our first like 512 cluster for Amazon GPUs as well as Google GPUs, right? We just sort of like got it from friends who are customers when they briefly had downtime. But like when we looked at CoreWeave, we were like, what the heck is this? This is complicated. This doesn't make intuitive sense to how we've ever scheduled jobs, right? It's you just use Slurm, right? Like you mentioned, right? Anyone who's going to school learns how to schedule and does like HPC type things, schedules jobs on Slurm, right? The university clusters all run Slurm. Why? You kind of mentioned the motivation, but like kind of, I'm sure many customers push back. Maybe some push back for a short period of time. Some customers push back for a long period of time.
You would be surprised, to be honest. I expected that as well. But like what we see is the customers who have their own infra teams, they are like the infra teams traditionally. The infra teams seem to like their Kubernetes clusters and operating things in a cloud native way because they can use GitOps, they can use these modern tools. So they're sometimes over the top ecstatic that like be able to manage all these environments the same way, because usually they have a Kubernetes environment for inference and so on. So their reception has been much better than I expected from the infra teams. And then from the user teams, like they really don't have any difference. Like when you run your S-run, when you run your S-batch, launch your jobs, you still have your mounted file systems. Like from a user teams, there is no difference. And we have some significant customers who have some significant on-prem deployments of Slurm, and also Slurm in other clouds, and their users have like no idea to run on CoreWeave Slurm or Slurm or Kubernetes. It's just, if you use modules, you want to prepare your images, in our case container images with all the dependencies, but like the users have no idea at all. And for the operators, when the operators like know what it is, they operate it like they would do their cloud native tools. And you don't like to get your Slurm CTLD logs, you don't cat a file on the file system, you check a pod log, or you go into our Lookie interface to get the pod log, but then you have proper search tools and correlate it. So it's like you have the logic ingestion pipeline, you have all the tools that you want to run a production system. So I would expect more pushback, and like I really, really get very, very little of it.
What's funny is there was a customer that had more than 10,000 GPUs with you. They got acquired. They had to start using some clusters at their acquiring company, the company that acquired them. And all of their engineers were like, wait. The infra team was like, wait, we want what CoreWeave has. We don't want this other thing. And I thought that was like a very unique experience or thing to like have someone say, hey, you would just assume the hyperscaler stuff is just as good, and CoreWeave is just like the underdog. But actually, users are clamoring for the CoreWeave Sunk system
like how to manage
and the storage, right, which was better performance than the hyperscaler storage.
Object storage, yeah. So I mean, so Sunk, we actually some of our significant customers they run our Sunk on other clouds and even on-prem, which is pretty awesome. So I didn't expect that at all. And then we have like if you say the customers who don't have their own infra teams, they just want a Slurm environment. And since it's so easy for us to spin these things up, like if we have AI labs, smaller AI labs, like say 64, 256, 512, maybe even 1K GPUs, don't have an infra team. They're like, I just want Slurm. Then since it's all cloud native for us, like we spin it all up. We have a button. Then we can even do a managed like shared Git repo if they want to tweak some things. But like it's so easy for us to co-manage them because it's all proper infrastructure as code that we can spin up a Slurm environment for them. They don't even know actually it's Kubernetes under the hood if they don't want to, because they just want an environment to run srun in, and then we can deal with all the admin.
Zooming out again, what's next, right? Like you've got one of the most reliable clouds, if not the most reliable cloud. You've got great security. You're the fastest to the new GPUs. Obviously, there's one end of the market that is just like, give me bigger cluster, bigger. And you have close relationships with at least one of those companies, and it seems to be more on the silent end. But when you look at the other end of the market, right, the majority of the market is going to be running towards deployment, towards inference, towards scalable services again, right? Right now all your contracts are long term mostly, which is good for like financial health and position. But like, how do you see the evolution of like, well, actually this workload is scalable and it needs to scale up and down a lot, and actually this workload requires some more software to do inference effectively or to do sort of many other tasks effectively. Where's CoreWeave's role here going forward?
That's a great question. I'm going to try to answer it as well as I can. Now, being a public company, I don't want to get in trouble. So
you've been coached too well, man.
Yes,
I need some beers in you before we record.
Yeah, exactly. I'm just too scared. We have a big legal team now. So there's two answers to that question. So some of these are very obvious public. We just closed our acquisition of Weights and Biases last week. It's a fantastic team built a fantastic product, and they have a great reach. And their engineering team, they're very similar to ours. Like
for reference, Weights and Biases is for like helping you train models, you monitor, you kick off your experiments in there, etc.
Yeah.
You track them.
Exactly. And they have a very broad enterprise use base, and they're great at building tools that people love. So we're gonna evolve on that. And kind of use that to reach the more mass market users is the plan. I can't talk exactly what products we're doing there. They do both training, inference. There's going to be stuff in both those realms. So that's kind of to reach we go really really broad. That's why we have Weights and Biases. But then we're also going to have continue to have really large customers that are also going to do stuff like do more stuff in inference. I talked very early about how back in 2020, Stability AI 2022, we had this really advanced inference stack. Our Kubernetes structure looked very different back then. It was actually multi-tenant Kubernetes, so we could do really fast auto scaling up and down in seconds. Stuff that we don't necessarily have right now in the bare metal model, but we're investing in getting a lot of those properties back without losing any of our security guarantees. And there's a lot of very advanced stuff going into like how do you reboot a bare metal server in seconds instead of 20 minutes. Not going to go into details, but there's a lot of work that goes into doing that and still keeping our security posture, security boundaries. So there's a lot of innovation to broaden the use cases, back to where we were before with super elastic inference and so on.
And with this elasticity, I mean, it's also the on-demand side of things, and you guys don't really offer that today. Why is that, right? I think I know the answer, but like, yeah.
I mean, the reason it's funny because on our product like planning calls every month, it's like, okay, on demand launch, and then we sell out all the capacity. So like the true answer is we try to build as much capacity as we can, and we're building an insane amount of capacity, but
damn you, sales team, you're too good.
Yes, pretty much, right? Like with our reputation, like that we can build quality compute. We just somehow sell out. And
at the end of the day, you'd rather have a multi-year contract, right, than on demand.
There's pros and cons with both. But yes, the finance team definitely loves the multi-year contracts. But there's a lot of features we're building around, like making on demand, more creative, like on demand, just putting a sticker price on a GPU is going to be is a tough place to be, because either the sticker price is going to be too low and you actually don't make any money, or it's going to be too high and people don't pay for it. So trying to find some middle ground where we come up with some new product models, new financial models, like how do you tweak this a little bit so that customers don't have to write the 3-year commitment, but it's also not necessarily like a 1 hour thing, or things we're thinking about as well.
Interesting. Yeah, you could have like slush funds of on-demand credits or something like that is purchased, and that makes
shorter-term
sense.
reservations. Like there's a bunch of things, and then maybe higher level services that abstracts away some stuff and allows us to be more fungible with the compute in the background.
Makes sense. And Peter, sort of to end it on a lighthearted note, I guess, we gave you a fantastic platinum medal. We gave all these other clouds gold medals, or there's the silver, bronze, and underperforming clouds we didn't give medals to. But Platinum Peter, as they call you in Slack allegedly, where's your medal?
Yeah, so this medal, and I'm really sad I didn't bring it today, but it's for a good reason. It's a pretty awesome medal. Like if you haven't seen it, go online, check the photos. So it's like this heavy chain, like I feel like a hip hopper, to be honest. Heavy chain, and then there's like this big metal on it that is all made out of metal. Like I figured that some part of it,
it's gold plated.
It's gold plated, so it's incredibly heavy. And me, given like the kind of insanity for the past 4 years, I haven't really done that much strength training. So when I got this medal, I was so happy. It was the first day of our offsite. I was walking around with this medal on our offsite, showing everyone like we're platinum, and it was great. And then in the evening, after wearing it for 12 hours, my neck hurts a little bit, and I took it off, and now my neck has shooting pain for 2 weeks. I'm not even kidding. This is so embarrassing. And I've been to
workers comp.
I've done I've done massages. I've done chiropractor, and it still doesn't go away. So now I'm kind of when I look at a medal, it's a little bit ooh. I'm very happy over it, but I don't think I'm going to put it on again for a while.
Or just put it on for short periods of time.
So now we're passing it around so different people get to wear it, and then I'm trying to share the.
Okay. Now you can do an employee of the week or month, or
exactly.
Team, and you get to keep the.
And I also get to see who goes a little to the gym as I do. So.
Oh my gosh! So you're the that's why CoreWeave software is so good. They've got a nerd who doesn't go to the gym.
Yeah.
Well, thank you for your time, Peter.
That's it. Exactly. Thank you, Dylan. This is great.